Today, we'll be covering another beautiful topic as we take a journey in expanding binomials and polynomials. So, stick around and let's explore this beautiful topic together. This lesson will be covered in 3 parts. Section 1, expanding single brackets, and Section 2, expanding double bracket. Final section, Section 3, we will be expanding triple brackets. Each part will have its own independent practice questions and answers. By now you're getting used to this to help you cement your understanding. So guys, let's start by looking at what we mean by expanding brackets. Expanding refers to the process of simplifying an expression or equation by multiplying out brackets, combining like terms, and eliminating common factors where possible. Now, in order for us to do our expanding or multiplying out our bracket and simplifying successfully, it's important for us to talk about what are like terms. So when we talk about like terms, we're talking about terms that have exactly the same variables and also the same exponents as well. And by exponents, we are talking about the powers. So let's have a look at this example. So we've got 4x minus 2x plus 8 plus 3x minus 1. So I've color coded here the like terms. So 4x minus 2x and 3x are all like terms because they have the same variable, which is x. And 8 and minus 1 are also like terms because they are numbers. Okay, so if they've got like a square, so let me just write this here. So what if I had 4x and minus 2x squared? These are not like terms at all because one of them is x and the other is x squared. So they've got to be exactly the same variable. Very important there. So how do we expand our single brackets? So to expand single brackets, we follow the steps below. Step 1. We need to multiply each term that's inside the bracket by the term directly outside the bracket. We've got to make sure this term is exactly directly outside the bracket. If not, then we cannot use it to expand the bracket at all. Step 2, we need to list all the terms. And after we've done that, we will collect and simplify the like terms where possible. So it's not always possible to simplify because we do not always have like terms after we have expanded the bracket. Beautiful. So we go straight into some examples. So we're asked here to expand the following brackets. So in part A, we're given 5 on the outside of the bracket and y add 3 on the inside. So remember, first step we talk about was to use the term directly outside the bracket and multiply both of the terms that are inside the bracket. So I'm just going to rewrite this here. I've got 5y add 3. So what I need to do is to do 5 times by y, which gets me 5y, and 5 times by positive 3 gives me positive 15. Now, there is no like terms here because I've got a variable term and also a constant. So a letter term and a number term are not like terms at all. So that is my final answer. So now I go to part B, where I've got 3 on the outside of the bracket to be multiplied by x minus 7. So I write that again, 3x minus 7. So I need to do 3 times x, which gets me 3x. And 3 times negative 7 gives me negative 21. Very, very simple execution there. So now we go to part C, where we've got 10 and in bracket a plus 2b plus 3c. So this time there are 3 terms inside the bracket. So I go ahead and I rewrite my question. A plus 2b add 3c. So I need to do 10 times a, which gets me 10a. Then 10 times 2b will give me 20b. Then 10 times 3c gets me 30c. Again, I've got a, b, c, so there are no like terms at all since none of the variables are the same. Part D gives us a negative 5 on the outside of the bracket. Then I've got AA minus 7w plus 7y. So again, 5 minus 5, I've got 8a minus 7w add 7y. So again, distributing, minus 5 times by 8a gives me minus 40a. Remember, pay attention to your signs. Negative here times a negative will give me a positive. So this will give me positive. 5 times by 7 is 35. And I've got my w as well. So positive 35w. Negative times a positive gives me a negative. So negative 5 times 7y gives me negative 35y. So again, all the terms have a different variable. Therefore, no terms to be collected here. Hence the question just said, expand the following. Very good. So now we're going to go on to look at another set of questions. Now this time we may have some simplification to do by collecting the like terms. So here the context of the question has changed. It says expand and simplify the following expressions. So part A, we've got 8w to be expanded with 3w squared. So we've got a square involved this time, plus 3y. So let's rewrite 8w, 3w squared plus 3y. So I go for coefficients. 8 times by 3 is 24. And then w times w squared gives me w cubed. Very important to note that. So I've got a plus here. So 8 times by 3 again, that's 24. But w times y gives me wy. So in this question, no like terms as well. We now go to part B, where we've got 2 sets of brackets to expand. So if you can see here, 5 is being distributed to 2x minus 3, and minus 3 is on the outside of the other bracket being distributed to 4. To x add 4. So we must expand them both, and then when we're done we look if we've got like terms and then collect the like terms to further simplify. So we're going to go ahead and we're going to do 5 and 2x minus 3 first, and then we will do minus 3 and x and 4. So off we go. 5 times by 2x gives us 10x. And 5 times by minus 3 gives us minus 15. Then we go to the other bracket. Minus 3 times x gives us minus 3x. And minus 3 times positive 4 will give us minus 12. So very important to use our signs properly. Now that we've expanded them all and listed the terms, we can see here we've got 2 terms in x and also 2 constant terms. By that I mean the numbers. So I'm going to collect my like terms. When I'm collecting my like terms, I must pay attention to the signs. So here I've got 10x, take away 3x, that leaves me with 7x. Then I've got for the constant minus 15 minus 12. So when I'm combining 2 negative, this is like I owe 15, I also owe someone 12. So I need to find out how much do I owe in all. So that will give us minus 15 and 12 is 27. So now I have collected my like terms. A very good opportunity for you to like this video as we play on those words there. Beautiful. So we go to part C. Same principle apply. using the distributive law, we are expanding using the term that is directly on the outside of the bracket. So I do 3w squared times 7. 3 times 7 is 21, so 21w squared plus, I'm doing 3 times 2 here, which is 6, and w squared times w squared will be w to the power of 4. So we've got to add the powers together. So again, these are not like terms because one of them is a w squared while the other is w to the power of 4. So we move to our last question on here, then we're going to do just one more question involving a shape, and then we will look at our key takeaways. Beautiful. So we can see for this question here, there are 2 brackets that we also need to expand, but we've got a single x on the outside of the last bracket. We do not do anything with that x at all until the end when we are simplifying. So I'll rewrite, so 2x minus 1, add 4, and then we've got 3x plus 3, and then I've got a minus x. So we're going to expand the brackets first, and then we bring back the final minus x at the end. So 2 times x gives us 2x, 2 times minus 1 is minus 2, and then positive 4 times by 2x is 8x, and then 4 times by 3 is 12. And now we put back our minus x at the end. Now we will collect our like terms. So I've got 2x plus 8x, which gives me 10x. And then I've got positive 12 here minus 2. So 12 take away 2 is positive 10. And then I'm going to just deal with the x at the end here. So again, I could have just done it all at once, but sometimes it's better to just collect first and then further simplify. So 10x minus x is 9x. And then I've got a plus 10. So the final answer then is 9x add 10. As I said before, we could have just done all the x, so I could have done 8 add 2, which is 10, minus the extra x at the end, which would have gotten us to 9x straight away, but our constant is 10. Absolutely fantastic. So now we're going to do our final example, and I've integrated here the perimeter of a triangle. So the question asks us to calculate the perimeter of the triangle shown below. And then what kind of triangle is it? So we do not answer that part of it until we have expanded the brackets first of all. Then we'll see if we've got any sides that are the same and then follow that principle to name the shape. So we want the perimeter. Remember, the prefix peri means around and meter means to measure. So basically what we want to do here is to find out the distance around this triangle, but it's going to be in terms of an algebraic expression since we haven't been given actual numbers. So I'm going to go ahead and work out what is the expression for the first side. So I'm just going to call this side 1. So it's 4 bracket 3 minus 2m. So let's expand. 4 times 3 gives me 12, and 4 times minus 2m is minus 8m. So that is the length of that side. Let's go ahead and do the length of side 2, which is 4 bracket 10 add 4m. So I'm going to do 4 times 10, which is 40. 4 times by 4m is 16m. So that is the length of that side. So let's find the length of side 3. So I've got 8 bracket 5 add 2m. So we need to do 8 times 5, which is 40. And 8 times by 2m is 16m. What do you notice? I can see here that after expanding my brackets, 2 of my sides are exactly the same. 40 plus 16m, and also the other side is 40 plus 16m. So I can now answer the part what kind of triangle it is. It is an isosceles triangle. So I'll write that here. Isosceles triangle. And that's because two sides are exactly the same. And if two sides are exactly the same, it means that also two angles are also the same. So now we're going to combine them by finding the perimeter. So the perimeter would be equal to 40 plus 16m plus 40 plus 16m, and then plus 12 minus 8m. So I'm just going to put a star beside all the ones I'm adding together. So let's go now, collecting our like terms. Let's add all the m's together first. So I've got 16 add 16, which is 32. So I've got 32m take away 8m. I'll simplify that after. Then I've got 40 plus 40, which is 80. 80 plus 12, that's 92. So for the constant, I've got 92. So what is 32 now? Take away 8, that is equal to 24. So I've got 24m plus 92, which is the perimeter of this shape. So we've got to leave our answer like this as an algebraic expression. Absolutely brilliant. Awesome. So what we're going to do now is our key takeaways. Thank you so much for getting this far in the video. So, key takeaways. Remember, we talked about that expanding refers to the process of simplifying an expression or an equation by multiplying out brackets, combining our like terms, and eliminating common factors if this is possible in the question. We talked about the fact that like terms, they have exactly the same variables and also the same exponents. And we looked at an example where we talked about x is not a like term with x squared, because one is a power of 2 while the other is just a power of 1. They've got to be exactly the same. Finally, we looked at the fact that once we're expanding single brackets, step 1, we go ahead and multiply each term inside the bracket by the term directly on the outside of the bracket. Step 2, we list all the terms out, and then finally we collect and simplify where possible. And of course, we looked at examples where there were no like terms at all, so when we finished expanding, that was the final answer. Okay, now guys, have you liked the video yet? If you haven't done so now, you need to hit that thumbs up. Also, remember to share and hit the notification bell, as part 2 of this lesson will be coming out soon as well, where we're going to be looking at expanding double brackets or two binomials. Absolutely brilliant. And also remember, your revision material is also on TikTok. So guys, thank you so much for watching.